Hey, what's up everybody? Welcome to the pre-show. Good morning everybody. We are live streaming on YouTube's this morning. It's Wednesday. I believe it's Wednesday, July 19th, episode 146.
That's right, we're back to our Wednesday schedule lineup of 3D printing. Thank you all for joining all across the globe.
Yeah, things are going well. Just setting up the show stuff.
Got an exciting jam-packed show for you guys.
I'm still like loopy from last night because I uploaded the video at 12 a.m. I went to sleep like at
it's our new schedule. We launch everything right at noon or right at midnight.
Right. So if things are missing, I won't know for 8 hours or less. And it looks like tweets are tweeting.
Quick shout out to everybody in the chat room. Thank you all for joining us before the show. Andrew, Yanni, Ryder, Kirby.
Hello, everybody.
Tech Guy 12, Jim, 2386 is in the house.
And I have a Discord chat link for everybody in the chat room. You want to, whoops. I almost deleted the chat room.
I forgot the quick link. What is it? Discord dot, no,
Adafruit. Adafruit.it/Discord. Yeah. Hello, everybody. I think it's HTTPS. Adafruit IT Discord. There you go. Yes. Wubba lubba dub dub.
That was it. That is it.
Yeah. V23 looked pretty awesome. Right? I didn't get to see all of it, but I did see we posted something on the Adafruit blog, like a look at the Star Wars land or something. It was like a flyover 3D render. It's pretty neat. I gotta say, I can't wait to check it out. It looked massive. It was like, whoa, this is like too big.
Was it 14 acres, people are saying?
I have no idea.
I have not watched any D3 videos or anything.
Yeah.
All I see is tweets or like quick snippets of news.
I've been in the dungeon working on this robot for the past like week, seems like.
More people coming into the chat. Benji, Galactic 3D, Rich.
Hello.
Remsky 8, Christian, Andrew.
Oh, with the Q&A, we have people asking us questions. Hello, Andrew. He's asking, how can I reduce stringing?
Either temperature or retraction.
More retraction. And less temperature?
Wreck-It Ralph 2? Is this where he wrecks the internet?
Yes. I think I saw a teaser or something that was like recorded on a cell phone. What is today about shields? Yeah, a different type of shield, not like an Arduino shield, but more like a cosplay shield.
Galactic 3D said he is going to order his first parts. You got 1 minute, I think, if you want to get your order out of the door. What's the coupon code?
Coupon code this week is ServoLED.
You got 1 minute to get that order in.
Really?
I think so, right? Everything before 11, that's when it ships out.
I guess so.
If not, you should be able to get it by Friday.
Yeah.
You got 1 minute? Oh no, I want more coffee.
Yeah, mine's getting cold. I need like a heating pad. I need to make a heating pad. Agents of S.H.I.E.L.D. All right, well, it's just me today. Pedro's gone.
Start the show. I'm just heating up coffee.
Later. What is the 805, Kirby? Whoops. The slide switch, yes. Can't ever have too many of those. You need to get some rocker switches. Those are so fun.
Gotta rock out with them rocker switches.
Oh my goodness. Christians started printing Ninja Flex. Ooh. Cheetah.
Nice.
Yeah, Cheetah's definitely a lot more friendlier than the 85A stuff. I haven't printed Ninja Flex in a good minute. Been focusing on just regular PLA. Yeah. All right. Well, the show is happening, so let me do a quick rundown on my buttons work. Okay. Let's start the show. Yeah. All right. Here we go. Hey, what's up, everybody? Welcome back to another 3D Hangouts. I'm Noed, designer here at Adafruit, and joining me every week, this guy, Pedro.
What's going on? Right on Pedro Rose, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
Why, yes, this is the show where we combine 3D printing and deal with electronics to make inspiration projects for the world. Hello, everybody. Let's start the show off with this week's coupon code. I believe it's this one. Yeah.
Servo LED is this week's coupon code. Use that to get 10% off your order.
Yeah. To pick up some servos and maybe some LEDs. Yeah.
Of course, filament.
That's right. We also
3D
have.
printers?
That's right. There's a lot of different things. We also have some special deals going on with UPS. It's kind of like a year-round deal thing. If you order $200 or more, you get free UPS ground shipping for folks in the U.S. continental. Check out the website for more details on that. We still have same-day delivery, which is something that happens if you're in a certain zip code in New York City. So if you want your stuff delivered in the same day that you order it, you can do that. Check it out. We still have our daily newsletter stuff going out. So you have to opt into that if you want some daily newsletter stuff. We have biohacking and CircuitPython and 3D printing, of course. We also have a news letter specific for products. So if you're interested in just Adafruit products, you can check out that at adafruit.com/newsletter. We did have a deal going on with the free pins, which has been going on for, I think, a month now. We are done with that deal. So I think we ran out of LED pens. So everybody who ordered, thank you so much. If you have an LED pen, please take a photo of it and share it on the social so we can retweet it. Because I didn't get one, and those are like so limited.
Either.
Yeah. Even though my order that I would put in like says I would get one, I didn't get one. Only for real Adafruit customers. We got a Discord chat. Check it out. Shout out to, Scott for setting this up.
Yes,
yeah, and Ryder, he inspired. He kept asking us about it, and finally did it. So awesome! Check it out. I am there right now, and
yeah, we could have like a little screenshot of this. See what. So you can see all the different categories we have. We have.
You want to see it? Let's
project help. We have code of conduct. We have live broadcasting.
Here's the welcome chat room. Here it is. There's a code of conduct, so make sure you read that.
So this is definitely like the heart or the pulse of Adafruit. So you can see everything that's being released down to GitHub, pull and requests, pushes, to everything on Learn that's been published, as well as
there's
all the YouTube
much cool stuff in here. So whenever I upload something to SoundCloud, it'll like get notified right here.
So everybody asking for what music was that? Where do I get that song? You can see all of the new, freshly published tunes.
Yeah, they're all like RSS feeds that are set up with ifty.
Yeah, they have some really good webhooks. So Scott was able to go down on these for all the RSS.
Same thing with all that data. All the Learn guides.
What is this new thing we have? Dog pictures and cat pictures.
That was great. I miss my cat.
The Discord banner was designed by Noah, right?
Yeah, sure.
I think you did this.
I just threw it together. It said they have like a brand thing when you go to the Discord site. It's like, please do not obscure our logo. So I tried not to do that. But anyway, yeah, check it out. I got the link for you in the chat room and stuff. So we'll be here in the 3D printing part. Hey, Tannen is in Tanute. Scott is in the chat room. He's actually at HQ right now.
Yes, if you guys didn't get a chance, check out the YouTube channel. You can see Scott and Phil flying the drone around in the office, showing off his super awesome little tiny keyboard that he made, all MicroPython. Looks super awesome.
CircuitPython.
And then some really cool robots that we got in from DHL. You can see it going around the factory with Lamar. Check out the YouTube channel for that. Subscribe, hit that bell icon so you can get notified when new videos are uploaded.
Sweet. Thank you, Pedro. All right, well,
let's go ahead and jump into this week's super awesome project.
Yeah, this week was the release of our Guardian robot from the video game Zelda Breath of the Wild. So, super awesome project. This was actually designed by Steve Ebleton, who posted it on Thingiverse, and I saw it and I was like, wow, this thing is amazing. So, a lot of people from the community kind of remixed it. So some people asked Steve to make a dual extrusion version, and other people remixed it to put a servo so that the head would turn. So that's how it kind of started off. And let me see if I can get to the Thingiverse page here. So this is where the Hackable Robot is. So this includes different versions of the robot. So depending on if you want a dual extrusion version, there is that. You can also get a single extrusion version, where you can optionally like paint the surface depending on if you want to add LEDs or not to it, or you can just add the servo head. So you can kind of do your own thing to it, which is really cool. I really respect that. But yeah, it's kind of was inspired by other open source designs, kind of like the Makey robot and some of the articulating gripper arms. So Steve put this together, and his son really wanted like a replica of the Guardian robot, so he whipped it together, and it looked amazing. So yeah, the community remixed it and wanted a servo, wanted dual extrusion. For me, I downloaded the dual extrusion version and it wanted to make it more of as a test. Because I got the Ultimaker 3 and I've been meaning to do some more dual extrusion, so this was a great opportunity to test it out. As I tested it out, the first video that we put together with just the LEDs and the claws, that grew very, very popular, and a lot of people were requesting to add an LED to the eye. So I built a quick little prototype, and I kind of fumbled around with it a little bit because I haven't worked with servos too much. So my contribution to the project was making a bottom cover that would house the electronics. So coming up with that and then figuring out the circuit was straightforward, and I put that together. A little bit back and forth on figuring out like kind of the best way to go about assembling the circuit, because it's more like about kind of wire management than anything else really. So at first I kind of wrote some really rudimentary code to do kind of pre-programmed movements. So the servo would rotate in one direction, and then the blink would happen. Like, it was very kind of stale, right? Mm-hmm. So it needed some more randomness to it. So I asked Phil B, who is our software engineer at Adafruit team, and he wrote some nice code to make it random. So he randomized it so that the movements of the servo is random with the blinking. So they're kind of independent from each other too, so you kind of get this nice organic motion from it. Really simple too, so pretty neat. So let's go ahead and walk through the guide real quick, huh? So if you go to the Adafruit Learning System, you can check out the guide for this. Let me go to the preview link so you can kind of see a better look at it. So the first page just talks about the project, links to, of course, the Thingiverse page, and talks a little bit about the dual extrusion. Again, if you don't have a dual extruder, 3D printer, or a 3D printer at all, you could use a service like 3D Hubs, get somebody else to 3D print it, and then you pay a little bit of money for them to print it and ship it to you. So there's just lots of options out there. So it's just if you don't have a 3D printer, you can totally still do this project. With most of our projects, you can do that. So I walked through a little bit of prerequisite guides, just some kind of info if you're very new to this project. Don't shy away from it. We do have lots of different guides to get you up to this. So a nice guide by Colin, when he did Colin's lab soldering video. So that's a really popular one. All About LEDs is a guide that was written by the Cooper brothers, that just talks about LEDs in general, like resistors, values, how to pop them and not pop them. Introducing the Adafruit Trinket, so setting up your Adafruit Trinket with the Arduino IDE, installing it through the board manager, getting that stuff set up. And then I actually broke out a guide, made a dedicated guide on just making a JST slide switch adapter, because I use them in so many projects. It's another great example of like, wow, I'm happy I put a guide together, because I don't have to dedicate a page in the guide just for building a slide switch.
It's always helpful when you can link to something you've already created a guide for.
Yeah, totally. So that's what the prerequisite guides are listed there. A good handful of parts here. So the main thing is really the servo and the Adafruit Trinket. The LEDs is sort of like if you want your thing to light up, you can do that. The breadboard PCB, if you don't like cutting them, I would recommend using a flexible PermaProto PCB. A slide switch and a battery. For the battery, I originally used 150 milliamp. Mm-hmm. It dies in like 10 minutes or something. So I'd throw a 500 milliamp in there. It's not too much bigger, and it still fits in the body. Cool tools, right? So I'm a big fan of just using third helping hands and pan devices, and mounting tag.
Like just mounting it to like
just free,
whatever surface.
Whatever works for you is fine, but I do recommend using them because
a lot of the time I need to get underneath the board to solder. Yeah. Or add solder to like the bottom part of it. So
yeah,
super helpful for that.
Quite a few shots in the video where it's like that didn't work. You know what I mean? Because you're looking from the top and it's like that looks like it worked, but you looked underneath it and it didn't even connect. So it's kind of funny. Anyway, those are the tools. I always break out my tools here for it. Let's talk about the circuit diagram. So one of the things to make it easier to wire grounded voltage connections is to just add a little strip, a little grounded power rail to the Adafruit trinket. So I took a Dremel tool and I cut off a little piece of the power and ground rails from a quarter-size breadboard PCB, the Adafruit Prima Proto PCB. That way I can have just more voltage and ground connections. So we need a couple of different components to connect to voltage and ground. So the LEDs, of course, and the micro servo. So when everything routes into that, you don't need to share pins because you just have more of them.
This was super handy. Usually I take a flexible PCB, cut that up, but because we needed this to be nice, rigid, to be able to adhere to the back of the trinket, man, I wish we had quarter-sized.
Yeah, like nano-sized perma-protos. That'd be nice. Kind of like the size of the trinket. But anyway, that's why we have the flexible PCB. That works well too. If you're embedding the project, you're not touching it. I'd say go with the flexible PCB. Yeah. Cut it with scissors.
I just like how the thickness of this is.
Yeah, it's FR4, man. It's dirty stuff.
So you definitely want to be careful when you're cutting this up.
Yeah, I talk about that too in the other sections. So wired connections are all listed in format there. I broke out this strand of LEDs into its own little guide, or its own little circuit diagram, just kind of show you how they're wired in series. So they're not programmatically controlled, they're just on, so it's mostly for aesthetics. So again, you don't have to do this part if you don't want to, but if you want to fashion your own LED strand, you can totally do so. Here's the software bit, so I walk you through setting up the trinket, so I link to the guide there. You do need the TICO servo library. This is a library that's kind of special for the trinket to work with servos and neopixels. Even though we're not using neopixels in this project, it's still a good library to use for our little micro servos. So install that with either the boards manager in Arduino or manually installing it by downloading the library from GitHub and popping it in your library folder.
Yeah, so it's handling the interrupts, right? Being able to run
it's managing the pulses.
Okay.
Yeah. Pretty cool.
So definitely handy.
Yeah, so real quick, I'll kind of briefly walk through the code a little bit. So the first stuff kind of defines what pin. I definitely recommend sticking with these pins. Don't change them. So the LED goes to pin 0, servo goes to pin 4. I made the mistake of attaching the servo to pin 1, and the problem with that is the bootloader, when it loads, it's actually... The bootloader is programmed to tell the LED on the board to kind of flicker and pulsate, right? And that's wired. That happens to be wired to pin 1. Well, if your servo is on pin 1, the servo will just start animating and moving with the bootloader. So it kind of broke my servo.
Yeah, you gotta be careful.
It broke my servo. So leave it on pin 4. All right, unless you want to change the bootloader. So we walk through the kind of setup here. We're setting pins high, like the LED pin, and defining them. And then there's some special like power code for the trinket. As you can see here, 60 megahertz trinket requires setting pre-scale for correct time. Okay, so this is timing stuff, not power stuff. We're walking through the loop, and basically there's 2 if statements saying like turn the LED on and off, and while that's happening, do the servo, like move, kind of set a minimum and maximum value for your servo, so that it kind of not rotates, but yeah, I guess it rotates between the 2. Yeah, so if you wanted to add more or less of the value, you can kind of fudge around these the min and max values up there in the top. That's kind of it. Kind of a rudimentary explanation of it, but that's as far as I can get with it. So I think this would make really great code for like a baseline for other cosplay projects, maybe even simple animatronics and stuff. So check that out. Hopefully it works for your project. The 3D printing aspect, I kind of want to update this page a little bit because I don't have any photos of the actual parts that were printed. I do have a little bit of the post-processing cleanup. There's just a little bit of extra kind of gook that gets on there because I didn't use a prime tower. When you're dual extruding, you have some options to kind of make it a cleaner print or not, but the caveat is it's more time and
a lot of
more waste.
Yeah.
So I went with the no waste and I'll clean it up later route. So that's what we did here. And
it's not too bad too when you take a look at the quote-unquote ugly side of where it's depositing.
Yeah, we'll take a look at it in a second here.
It's not too bad.
Yeah, so you can download all the models and stuff like that. I also have a Fusion file if you want to download. It's just the bottom part. Okay, so I'll walk through the LED eye. There's 2 LEDs that are connected together and then a little resistor to limit the current. So I fashioned together a little 2 LED
Which is a really
thing.
good way to do that.
You think so?
Yeah.
How come none of the GIFs are playing?
I've noticed that. There were some updates to learn.
Your GIFs are broke.
Make
the
things
thumbnail's working, but none of these are. These are all supposed to be moving.
It's whatever the element that's being used for the slide element, right? Is that what it is? That's the slide element you're using there?
Yeah, this is the slide element.
Yeah, there's something funky
no, that's
going
all
on
I
with
use for my guides. All right, well, we'll try to circle back around this when the show is over. So that's the LEGI. It's kind of the first thing I walk through. Next thing is, okay, so this is a big disclaimer here. Do not use a continuous rotation servo like I did here. It won't. It'll kind of work. Itself. It'll kind of work, but it doesn't do what it's supposed to do. So use a regular micro servo, the 90G ones, 90 gram ones, not the continuous one, because the servo or the library doesn't know how to kind of handle it, I guess. So don't use that. But most of the servos do come with like hardware, like horns, which is what you attach like the bushing to, and they come with hardware screws too. Most of them do, so you should have them when you get your servo. Wiring the trinket, again, a slice of FormLabs Proto PCB goes a long way. If you are cutting FR4 material, it is fiberglass, so you want to do it in a well-ventilated area. I did it in the garage with the door open and fan blowing out, so the world can get the dust. Maybe I should get a dust collector. But the flexible FormLabs Proto is a great alternative because you can just cut it with scissors. It's not as durable, but it is doable. Okay, hooking that up. Man, mounting tack is like something that's like, I use that in so many projects now. Mounting tack is just a nice way, a clean way to kind of attach two things together. I don't know what this stuff is made out of, but I use the Elmer's branded tack stuff, and that seems to work okay. One note though is that if you are soldering to something where there's blue tack behind it, be careful not to heat up the blue tack because it can like seep through the hole and mix with the solder, so that's bad. So kind of be careful when you're doing that. So I figured I'd write a note about it. And then just connecting, what am I connecting here? I'm connecting the LED eye to pin 0 and ground. So we walk through that, then we work on cutting the cables. So cable management is one of those things where you don't know until you do it. So just kind of keep your wires long and then trim them short once you kind of understand the kind of real estate that you have to work with. So that's always a good thing to do. I even cleaned up the wires a little bit more after this project, after I was done documenting, just kind of cleaned up a little bit more. Did I talk about adding a Jst adapter to the back here? Yeah, so adding a Jst adapter or just a Jst connector to the back of the trinket is totally doable. You can do that. And you can use mounting tack to hold it in place while you tin the pads and solder it in there. There's also two little securing pads. It's meant for like mechanical strength, so make sure you add those to the left and the right sides there. I wish this GIF was playing so you could actually see what I'm doing.
Kirby says if you click on it, it'll open up a page, but it will click, or it'll animate. Oh
boy, is that how we have to do it now?
Yeah, I've noticed that too. So we gotta ask Justin or Taylor.
It doesn't, and the timing is a little slower than normal.
Yeah, the
interesting. Anyway,
the speed that you select inside of Photoshop for exporting,
it does not keep the same. Yeah, it's weird. Okay.
What the settings were.
So anyway, once that Jst connector is in there, you can test it out with your battery and see it kind of struggle on the table to like walk because it has no feet. All right, so this section of the LED strand, completely optional. I actually suggest if you don't want to make your own strand, don't do it. Just buy this because it's already pre-made for you. I'm sure this will work for a lot of different projects. So if you're looking for a strand of just regular LEDs, you could, of course, wire them.
Wait, are you suggesting they cut that off to?
Yeah, I suggest doing that because cutting up a bunch of LEDs and the resistors, it's like an artsy, crafty project. It's very time consuming.
So this was actually suggested on your project for the arcade button box to get ourselves one of these so we can easily strip.
This is awesome. This is my favorite tool right now. So this is called the self-adjusting wire stripper. It's kind of beefy for what it is, but I like this one because it has a little set screw. So what you can do is you can fine-tune the set screw so that it can work with 30 gauge wire, which is that really thin stuff that we like to use a lot. But the cool thing about it is that it just looks cool, and now it lets you remove insulation from multiple wires, and it lets you kind of kind of create segments in line with a wire. So using this to create my LED strand was very useful. You clearly need
no.
But yeah, you can kind of create little cuts and pieces. Otherwise, you know the way I would do it without this is with an X-Acto knife, like painstakingly.
That's what I was doing. Yeah.
Kind of making a little opening or segment cut so that I can wire a component to the wire in line with the wire. Mm-hmm. So that's a really nice little tool. I actually picked mine up on Amazon for like 13 bucks or so. Right here, yes, 14 bucks. It's pretty nice. There's probably nicer ones, but I like this one. It's got a couple other features that I probably won't use, like the crimper, but it's there, so I like it. So that's the tool. Helped out a lot to create that LED strand. Mm-hmm. Final assembly. It's a good idea to test your diffusion on your part, kind of figure out where the LEDs kind of look the best. So add it there. I again used mounting tack to secure the LEDs to the inside lining of the robot. It's kind of hard to get in there, like your fingers, so I ended up using like tweezers to kind of set it in place. And then of course wiring the LED strand to the breadboard. So you kind of have to mount it first and then wire it. It's one of those weird projects where you have to kind of embed the electronics first and then wire it. So there you go. Okay, the last part is adding a switch to the battery so that you can turn the battery on and off. Because right now, if you just plug in the battery, it'll stay on until it dies. So it's always important to have that planned out for you. So that's what I did here. I have a little dedicated spot on the bottom cover print part to house a little switch and the battery. That just kind of snaps in between the little holder and the little platform for the servo. So closing this up together is a little bit, you kind of have to line it up properly. There are these little nubs on the side of the cover that kind of mate with the little opening notches on the bottom of the servo body. And so what you do is you just line it up and then push it in and it kind of twists to lock. But as you're doing that, there is a little notch on the platform, and this notch is kind of to have room to allow the 3 wires from the servo to kind of fit into. So this just kind of cups into there. So you just have to kind of orient it so that the notch is lined up with the servo cable, and then you just press the 2 together and then twist and lock. So I recommend kind of playing with that first before you actually install the electronics, which is what you normally do with 3D printed parts. Kind of do a dry fit. So that's it. Now you can turn it on. It was a lot of fun photographing. It's just a really photogenic project, so I had a lot of fun in the garage playing with it. One of the things I think would be really cool is to kind of remix this project, making it like as a baseline for maybe another cosplay project or like a cosplay weapon or some simple animatronic type stuff. It'd be easy to add a USB battery recharging to it.
Yeah,
with just a little time, yeah, just with a little backpack breakout. This little guy here, if you do want to. It's always nice to throw these in your project so that you can recharge over the micro USB port.
So it's a little bit difficult to tell what part is what.
Yeah, there we go. Yeah, it says it's for the Pro Trinket, but it also works with the Trinket. We have a couple of guides that show you how to wire it up. So that's always a good little add-on.
Super handy to add recharging capabilities to your project.
That's right.
Very good.
So that's pretty much it for the project. A lot of fun.
Now the moment you've all been waiting for. Let's see it over the overhead.
Okay, let's do it.
Okay, like you mentioned before, this was dual extruded on the Ultimaker 3. We did attempt to do this on the Sigma, but because we're using 175 on there, for whatever reason, it was able to do the head very good, but the fine detail parts, when it got right around here, it always kept failing, even when I increased the purge settings on it.
Yeah.
So standard settings on the Ultimaker 3, nothing fancy. We just used
No,
the
I actually used
default.
the 0.2 layer height. It's the default is kind of like 1.5. I was like, nah, I want it a little bit quicker, and it still took 21 hours.
That is the
3D
biggest
print.
drawback about this.
What is
using
up with
the
that?
Ultimaker 3.
Why does it
How
take so long?
slow, even though it was printing faster than the Sigma.
I'll tell you why.
Sigma
two
only
things.
took like 5 hours to print out of that. Of course,
5 versus 21 is
yeah.
big.
Of course, like I said, there was a lot of skipping. It wasn't able to get some of the finer detail parts on the body, but on the head it worked very well.
It did, yeah.
It looked a lot more better at 2mm layer height than it did on the Ultimaker. So the Sigma did win in terms of the quality for higher layer height for that.
Right.
But again, it wasn't able to print the body for whatever reason, even though I was using
skipping. Yeah,
yeah,
just that
skipping.
one part would skip. Yeah.
But
But
pretty
yeah,
close. Pretty close.
right. One of the reasons why the Ultimaker 3 takes so much time to dual extrude is because it's doing, yeah, the tolerances can get loose on those legs. Yeah.
So you take one of these off, you can see the articulation that's going on with these. So these are all printed individually, and then snap.
As you saw in the time lapse, what is it, 15 times 6?
Yeah, that's what we need. And if you still wanted to add LEDs to the feet, which isn't very accurate to the way that it is displayed in the game, you can still do that if you want.
Yeah, and even having blue lights here isn't too accurate. I just thought it looked nice. I did a mix of blue and red LEDs, just kind of give it some differentiation. But it looks cool.
And some things I don't think was shown in the video is that the claws actually articulate. Yeah. Take one off.
They're a little
claws there.
Finicky, I guess, depending on your print settings, so that they can fall out if you're kind of playing with them too much. Because it's just such a thin and small point of articulation.
Definitely not the easiest print in the world, but totally satisfying when you are able to get all these parts finished and assembled.
Yeah, and all the arms just fall apart. No.
It's the tolerances on these. Not all of them were printed with the settings that we use.
Once we dialed it in,
Once we dialed it in,
there's a lot of time to try out.
But because we had so many, I was like, well, we're going to have to use the loose parts. But here it is, all its glory. Super cool little desktop ornament. And of course, a nice little entry into adding servos, LEDs, all that schnaz into your 3D printed objects.
That's a cool idea. Scott is saying, what about using a NeoPixel so you can have it get angry? Yeah. That would be cool. So once it spots somebody, it would turn red. And
that would be super cool.
That would be really neat, they definitely could do it. You just got to make a little, maybe a diffuser cap thing for the NeoPixel, and then just wiring it kind of the same way, really.
So what I'm pointing out here is the little depositing side of the part.
Yeah, so this is like the Z seam where it kind of catches the loop as it's doing perimeters.
Not bad, but it looked a lot more cleaner on the Sigma.
It did. Yeah. But again, it had some kind of retraction problems where it was, or kind of gaps problems. But
yeah, there were gaps right around the little detailed parts of the translucent stuff. And I tried a bunch of different settings.
But that kind of adds to the actual overall texture to it, because in the game, it's actually an ancient robot. It's all rusty and mangled up. So it's not supposed to look polished and pretty. So they're kind of aged and weathered.
Christian is saying, why not add rubber bands through the holes to keep the tension on the arms from falling apart?
Yeah, I haven't tried that. That's a good idea. So elastic band would work well too, I bet.
Some people also suggested using some metal core so it can actually stand up on its own.
That would be really cool, some metal core wire.
So this is the really cool thing about having your object models being open source, being able to give away all your files, because everybody can go in there, remix it, make it better.
This wouldn't have happened if
this was behind a paid wall.
It would just make a little thing slower.
You wouldn't be able to have the community behind it to add all these different parts to it. So this is what's really cool about being able to give away your model.
Yeah, a good example of kind of collaborative.
Exactly.
Yeah, because it just we just kind of went with it, did it. It was like, okay, cool, and Steve's like, yeah, I'll work with you on it.
Yeah, we're actually gonna send Steve.
I'm actually gonna
fully
send him
assembled one.
Yeah, he definitely deserved it, because we did have a back and forth on kind of creating the details. Because actually, in order to make this diffuse correctly, you kind of have to cut the details all the way through the model. Yeah. So what we'll do is, I guess I'll load up Cura and show you guys how if you're doing a project where you want light diffusion to happen and you're doing dual extrusion, you want to have your details cut all the way through the model instead of just floating on the surface, because that's kind of like that's kind of okay if you're not planning to have lights in it. Do you know what I'm saying? Yeah. So, all right, so let's go ahead and take a look at the CADs, or just Cura, which is the slicing software for the Ultimaker 3. So hopefully I can quickly do this. So you find your files, right? And here's where there's a bunch of them. So there's a lot of different ones. There's some of the hips have little slots in them. So if you wanted to wire them or something like that, you could use that version. So what I'm gonna do is I'm gonna probably do the head details. Is it this one? Yeah, let's do these. So these are the two objects, and you can see in the base part, it's called part A, it's cut all the way through. So originally this was all enclosed, and the detail part over here would just rest on top of that, but that wouldn't work because the light won't be able to shine through the gray PLA. So you kind of had to cut it through. So I asked Steve to do that, and he was like, yeah, I can totally do that. So he hooked it up. So in Cura, to kind of do dual extrusion stuff, well, first of all, I recommend setting your, this is so much easier than other slicers to set up what material you want. So for example,
it's a little confusing inside some
yes, I didn't want to name names, but so I select part 2. If it was set to a different material, it would probably look better. Where would you do that? Under Ultimaker PLA?
Yeah.
And then like,
unfortunately, that's the only way to change the colors of these. Is
yeah, you have to kind of pick a profile thing and keep the setting, and then you can change this one over here. So you got 2 different tabs here, extruder 1, extruder 2. So all your settings for each extruder is independent from each other, so you can modify all your settings there. But for the most part, like I said, it's kind of default stuff. The only thing I changed was I put a 0.2 layer height, and I think I upped the temperature to 220. I think it was like 200 before, and I think I upped the bed plate to like 65. So that's really all I did. As far as like speed settings, all that's kind of default. So I didn't really touch much there. But whatever works for you will work, whatever kind of settings you have. I did use a brim on some of the parts to keep it down on the bed. That helps nice, and of course set it to whatever extruder you want. So to bring these two together, you shift select them, right click, and say merge models. So it'll combine them, kind of align them at their origins, and there, now you have your thing. Obviously you want to orient the part. I don't think there's a way to lay flat on the bed, right? Really?
It's like attempting.
Yeah, okay.
It's like, there's a suggestion. Let me click on what triangle should touch the bed.
Anyway, just rotate it with this here doohickey tool thing, and hopefully it snaps when you have it enabled.
I think your orientation's all messed up now by doing that lay flat.
Really? Yeah. Oh gosh. So don't do what I did. See, this is why we do this. All right, so let me go all the way back.
And the command key for this is Option Command G.
To group? Oh, okay, I see it there. Merge. Another thing is like you keep slicing over and over again.
So
you might
turn that off immediately.
I know. I like it on though.
It's good when you're like doing incremental, but not when you need to do a bunch of changes and you know what.
What is it doing?
What you're doing.
Okay, there you go. So that now that we futzed with it enough, there you go. All right, so let's take a look at the layered line so you can see inside there as I'm building the lines. So it's always a good idea to kind of preview your layers to make sure nothing funny's going on.
Absolutely, yeah.
It is a lot of data to kind of parse and slice, so it's kind of a big model. There you go. That looks pretty good. So you get a good visualization. You can see how thick these parts are. So there's very minimal material. Like all this is pretty hollow.
Just cut away, yeah.
And obviously I forgot the hips, because the hips are also separate. The hips are kind of articulating too. But as far as the infill, I tend to use a pretty decent infill. You can see, you can print this with no support material. So that's really nice.
Yeah, don't use any support materials on
Yeah, you could, but you don't have to.
It's going to be a little bit pain in the butt to remove.
Probably, yeah.
And you don't need it.
You really don't need it, yeah. So pretty nice. Originally I had the LEDs in these little cavities here near the hips, but it's just not true to the game. And
yeah, in terms of accuracy, they shine on
they
the
actually don't
upper side of it.
It's all this area that shines.
Well, if you do some Google searches, there are a variety of ways of where they're glowing, and the look of the Guardians are a little bit different. Yeah.
So that's pretty much how to slice it. As you can see in the bottom here, you get those holes for wiring, like elastic bands or something for the limbs, and then these little kind of curved slots are pretty smart. Like I was saying, the bottom part has these little nubs on the edge, and they actually slide into this and lock in place when you twist it. So really nice work there,
cool.
Steve.
Yeah, a lot of new techniques that
modeling kind of techniques.
Modeling techniques in terms of illuminating LEDs, having it shine through.
Yeah.
Stuff.
Oh, and then the head here, the neck area has these like little notches openings, so that they're kind of keyed with the head. So you kind of match up the keys and then twist to lock it, and it stays locked in place. Very cool. It's pretty neat. So cool. Very nice. Very nice.
Christian is saying that we still need a tiny sword for him to hold.
I need a tiny sword. I was thinking about that.
He did hold a little fidget spinner, which can speak to how.
Oh my goodness!
When you
wasn't
get
that
the
fun?
tolerances right on the arm, the amount of weight you're able to hold on there, because it's it's a pretty heavy spinner.
Yeah. Yeah, that was fun. Putting the spinner on the robot.
Yeah. So it's a really cool project. Hopefully you got a bunch of really good tips out of this in terms of modeling.
Yeah, I hope this inspires you
servos,
to
LEDs.
take the concepts, take the circuit, take the code, and work it into your project. So if you are a maker, cosplay person.
So you did release some of the Fusion 360 files, right? Or he released all of them, right? And then you added
Yeah, I don't think he released the source files, just kind of like the STL, so you can modify them.
Okay.
So, a lot of different versions.
One of the cool models that you made for this is the ability to add a slide switch facing upwards.
That's right.
So you can have it all on the bottom. It's something that I am using for my work in progress.
That's correct, yeah. So we can take a look at it right now, actually.
So we go.
Hopefully here.
So servo LED. I think one of the first things that comes to mind is like having this like a, I don't know, like a little puppet or something that's on your shoulder that has a...
I should put it on the shoulder for the show and tell.
Yeah.
Get some Velcro or something.
Mm-hmm.
Again, I got to replace the battery in there because it's going to die soon, I think.
Yeah, I can hear like the little static noise that happens when the battery's going down.
Yeah. It's like, all right, cool.
So that's this week's project. Check it out on Thingiverse.
Yeah, if you want the servo component for your CAD purposes, you can download the servo model, or go to GrabCAD, grab your own or something. But this one works well. Cool. Nice little mechanism for holding a slide switch vertically, I think.
I like it because it's been tested and you can update through parameters for adjusting to tolerances based on your printer.
Another tip, you see that hole there? That hole is so handy. If that hole wasn't there, good luck getting your battery out of there. How do I open this
sticking
thing?
your finger into
It's like a little opening hatch or something. I don't know. Kind of neat. Anyway, that's the project. Check it out on the Adafruit Learning System, on Thingiverse, and please watch the YouTube video because it was a lot of fun putting that together.
Yeah.
And if you want to pick up some stuff for your animatronic projects, use the coupon code SERVOLED and get 10% off your stuff. Sweet.
Pretty cool. So if we take a quick jump over into this week's WIP, what am I prototyping?
Paige is working on some
more Zelda stuff. Sounds like everybody likes the Zelda stuff. So
I like the Zelda stuff.
Yeah, I'm working on the Guardian Plus shield. So, of course, fully 3D printed. We got the giant blades on the sides here. Really happy with the way that the handle part on this came out. Just got to do a couple more adjustments. Reprinting this in the ice blue for all of the shield parts. Of course, we have a mini skinny NeoPixel strip inside here to eliminate all of the blades. Still working on that part, but everything mounts on the inside. It's all held together with the M2 12mm long screw, so everything can be completely disassembled for like traveling and all that. It's I think it's 15 parts altogether to print all these, but this will be coming out in 2 weeks. Just finalizing all of the dimensions for all the sizing and all that. And let me see if I turn it on real quick.
What I really like about this project is you're using really big nozzles to speed up print time, which is like the rate of which Pedro was able to print this, design this. It literally feels like a couple days, which is mind-blowing.
It was, yeah.
You know.
So usually with a 4mm nozzle, this would take like 5 hours just to print one of these blades. It's taken an hour and a half now.
It's crazy. Yeah, this takes like an hour to print.
That is the biggest tip right there.
Which sounds like, oh, that's a lot. But dude, compared to 5 hours, come on, it's crazy.
5 hours in, especially when you have to do tolerance adjustments, that's a huge amount of time that would be wasted just for updating parts. Since this is my 4th iteration of this, I was able to do in 3 days. For an entire... Like, what is this? Like, I didn't even measure this, but this is massive.
I don't know how big it is, but kind of your what do you call it? Your rule of whatever is don't get any bigger than the 12x12 bed on in the Type A. Is that your?
Yeah. But yep, this is what's coming up next. Continuation of all of the Armory cosplay props for Zelda.
I'm just sitting here cleaning up your parts, man.
I know. So there's some more detail parts to add. There's going to be a jewel in here to eliminate the yellow-orange color that happens inside of the little gems that are inside there. So there's still more work to done, but in terms of sizing and all that, getting the handle to all work, it all articulates, folds up, very nice.
It goes well with your Guardian sword.
Yeah. Where is that? There it is.
Right there, hanging on the wall.
These together. blam, you have a whole nice little cosplay little set here for any Zelda.
Chica Pedro over here.
Yeah. So super cool. We'll be coming out with this
So
in
much
2
Chica.
weeks time. About that, right? So super cool. That's what I've been working on there.
Great.
Of course, a lot of cool little modeling techniques and illumination with the LEDs. Tips that'll be going along with that.
Awesome.
So
What
stay
nozzle
tuned for
size
that.
was that, Pedro?
What's that?
What was the nozzle size?
0.6 millimeter nozzle that we're using on the Type A machines. Using two 0.6 millimeter nozzles on 2 of those to get all of this out the door.
Sweet. Thanks, John, for the comment.
Under 3 hours, yeah. Yeah, it is. So the wobbling that you're seeing is just from me, the way that I'm holding this, because this was mounted wrong. So I had to adjust that in the model. But in terms of the thickness for these, they are about 2 millimeters thick. So not super wobbly, but you can get some wobble in there.
It feels like 2 layers thick.
It's about 5 layers thick is what it is, yeah.
Oh.
But pretty cool.
Yeah, I mean,
if I make it any thicker,
in the game, there's a slight bow to it, so there is a curvature to it. So I think that works fine.
You definitely add that curve onto there.
You just kind of
heat it
like
up
a
heat gun or something.
Bend it.
Exactly, yeah.
Sweet.
That is what we're working on.
Sweet. Thanks, John, for the comment.
Raider's saying that we need to make a giant guardian robot now.
Yeah. Nice hexapod.
All right, let's go ahead and jump into this week's shop talk.
That's the show, Pedro. Oh, wait. We got a Tardis iPhone case. Or an iPhone.
This week's Timelapse Tuesday.
Yeah.
Oh, I didn't get the name of the...
I know. Dude, I've been up since, like... we go to Spinnerverse and Tardis Pi case. Give us a second, folks, while we load.
John's saying his son's a big Zelda fan. Yeah, we noticed everybody really likes the Zelda project.
It's all about
so
the Zelda.
Yeah, we'll just keep doing more as long as people keep watching.
Yeah. Okay. So this is cool. This is cool. Shout out to
Jst 3030 made this really cool.
Turn for Sun. This is great.
Totally current. I had no idea there was a new Doctor Who being picked out, and this definitely matches with current affairs.
This is one of the most unique Raspberry Pi cases. Making Raspberry things into Raspberry Pi cases is certainly like a thing. There's so many different Raspberry Pi cases, and a Tardis is perfect for a Pi case.
Yeah, so here it is in the flesh. Again, 6mm nozzle on the BCN Sigma.
Yeah, look at this thing.
Definitely sped up the rate at which we were able to print this out. Using a 4mm layer height on this. So instead of taking, I think it would have been like 8 hours, it took about 3.5 hours.
Top there.
Oh yeah, it did a really good job.
You want to do over the overhead?
Yeah. Taking a look at the window area here.
Yeah, so you can see a little bit of the gappage there. It's probably much more visible there.
It's probably because of the layer height. I should have did a 0.3mm layer height, but you can see that there are
maybe a little bit more extrusion multiplier, just to kind of over extrude just a tad.
Too, yeah.
So there's more plastic coming out of the nozzle. But as far as tolerances and
everything fit,
everything fit just fine, right?
Yeah. And I was especially happy with the detail of the lettering or the text set. You still pretty nice at a 0.6mm nozzle, so you have that balance between speed and detail using those nozzles. Really good.
Sweet. Yeah.
Yeah,
I'm really digging using big nozzles for big parts, quicker. You get a little bit less detail, but hey, when you're the scale of something, the layer lines just kind of, you don't even see them at a distance.
You can definitely see them.
I think it works
well.
well.
At the top, but there was no drooping.
Look at that
just a little bit of cleanup that you can do on there.
Yeah.
Did clean one of these up,
okay,
so you can see the difference.
The retraction stuff, yeah. So sometimes you just kind of get that on certain geometries. I mean, it's just very difficult to do that, especially printing that vertically. Look at that.
And I was printing this at, I forgot the setting.
It's fast, right?
It was
printing
60 or
90 or something like that?
Oh, you can even see the little door handle.
Oh my goodness. That is incredible.
Yeah. So if you want to try this out, and of course the Raspberry Pi is mounted on here, we're just using the M3 screws. I think they're about 5mm tall.
Oh, and the bed doesn't look like the bed was leveled that good. Looks like it's a little bit away from the nozzle. It should have been a little bit more squished.
Yeah, that too. So that's probably what's contributing to the gaps in here.
It really is bigger on the inside.
And somebody mentioned too how we were able to keep the corners from warping. We're just using blue tape on there. There was no heat on the bed. And that did a really good job of keeping that intact. So if you guys are looking for super current Raspberry Pi project case for this, really cool. I liked
it out for your son.
Yeah, all of the ports work pretty good. As you can see in the time-lapse video, the HDMI cable, all that was able to fit inside there. The only thing that's very difficult to get in there, once you mount it and you forget to add a little dongle for your keyboard.
Oh, yeah.
I had a heck of a time getting my fingers in there to plug that in.
The to-do here for you guys is to cut the model and add a little snap fit.
Or just, cut the top off here so you can pop that off. But they do, he did include a little opening to have like cables route out that way too. So very nice little simple design.
Yeah, nice vertically standing.
Like it.
Plenty of ventilation for your overclocking needs.
You can even stick a battery in there to make it portable.
Oh wow, yeah.
But super cool.
Add some lights.
Check it out this week's.
How long does it take to print?
3.5 hours.
3.5 hours. Okay.
Yeah. Again, with the 0.6mm nozzles.
Right, on the Sigma BCN 3D. Mm-hmm. Okay.
Yep.
Cool. Shout out to Jason for the awesome design.
Very cool.
Very cool.
And I think just a couple of things that I think we're still having those contest things.
Sure. So there's still some contests going on. It's an opportunity for you folks to win some really neat prizes, even 3D printers. So if you want to do some design stuff, you can do so. I think this one's still going on. This is a contest from Instructables. It's still the fidget spinner design contest. Is it over yet? You have 33 days left. Wow, 279 entries so far. So much fidgeting going on here. Too much fidgeting. Very awesome. Good luck to all the contestants. For your chance to win a Ultimaker 2 Go. Very cool. All right, so check that out. I'll put the link there. Let's see, what else do we have? We have another contest. That Bose build contest is still going on with Instructables. I believe you can still enter. There's 333 entries. A lot of this one. You got 12 days left. Here's some current ones. A lot of different kind of creative takes on this. Oh, that's neat. A little gramophone. That's kind of funny.
I like the
oh yes, of course,
one.
the Master Sword
yeah.
builds thing. Super cool.
A lot of nice little creative ones. I like the robot one, the Instructables bot.
Ah, look at that.
Build it into him.
Good branding in there. Sweet. Oh, the yellow submarine. Yes.
Of course, you gotta get a Goku in there. Super Saiyan.
With frog legs. I like the lighthouse still. That was a cool one too. All right, so check those out. Oh, I haven't been showing my screen. Oh boy.
What?
I wasn't showing my screen. So anyway,
so you just saw me
I did post. Yeah, probably. So here's the Bose one. I did show the fidget one. Sorry about that, but you can check the link out, and you can download the source files to get started. So you can use Tinkercad or Fusion 360, which is both really good free pieces of design software that are relatively easy to use. Okay, I think the last piece here is from My Mini Factory. I believe either that one is closed or still happening. Let's take a look here. This is basically over. Yeah, so the winners will be announced in August. And another one is from Pinshapes. This one we're actually...
this one just finished up, I believe, right?
Yeah, so we actually announced the winners of the mechanical design. We sponsored this one. Mm-hmm. So here are the winners. Honorable mentions. This is a 2016 Suzuki replica.
Wow.
It works, though. It's an actual RC. So that works. It's awesome. That's by Brett Turnage. That's a very, very detailed model. Look at that. Here's another honorable mention, a 3D zipper by Ronald. Cool. That's really cool. Here is a step clock by Make It.
That's cool.
And on to the prizes. So in third place is a piston bully. I actually shared this on the Adafruit blog a couple weeks ago. This is a 1/14th scale of a piston bully. So it's like this kind of, it's not a slope. Is it a slope? It's kind of like a snow plow a bit, I guess.
Some sort of plow.
Sweet. So he gets a $100 gift card for 3D Hubs. So that's really useful. The hand screw clamp by Jake. Yeah, we've shared Jake's work before. Very cool. It's a very useful type thing. That's second place. Mechanical design, $200 gift card, and the Prusa MK2S kit 3D printer. Ooh. And for first place goes to the Fin Gripper by Black Ram Industries. So this is like a prosthetic, robotic hybrid thing.
Super cool. We've seen the little gripper material. Part printed a couple times, but this is nice to see it used into a fully baked project where you can attach to your arm.
Sweet. Cool. So he's winning a FormLabs 2 and a $100 Adafruit gift card.
Nice.
How awesome. Very cool. Okay, so special shout out to all the fine folks, Prusa, 3D Hubs, and FormLabs. Do great work. There's also I'll probably show it next week, but the winners were announced too for the Fuse contest. Fuse design contest. I probably won't find it this way. There it is. So the winner, I think there's multiple winners, or is just one? Okay, so the top educational module is actually Josh Amiga, who goes by Design Make Teach on Thingiverse, Twitter, and Instagram. So this is really, really cool model that is kind of like is it the lunar lander, I believe? And it has kind of like a lithopane graphic of some hidden heroes. So check that out. Nice tutorial on how to do lithopanes on kind of curvature. Yeah, Hidden Figures, nice. Friendship 7. Isn't that awesome? Wow. So there's history in here. There's space design. Yeah. There's a lot of different kind of disciplines merging together to make this, which is pretty awesome. So shout out to Josh for putting that together, raising awareness. Cool. And the top design model art design is from Thomas Davis, who designed this amazing kind of rook looking with a dragon like sweeping through it.
Crazy amount of detail in that.
Yeah, that's crazy. And the top functional model, oh, I've seen this one. Yeah, this is from Dave Click. He designed a $30 3D scanner. A $30 3D scanner. Well, with your phone, of course. Hey, FormBot, how can we help? So yeah, congratulations to everybody who won, and there are still some contests out there, so there's lots of opportunities for you folks to win some fun prizes.
There you go. John says that was the Gemini capsule, a two-man spacecraft.
Awesome. Cool. Thank you. I need to read up on it more. Well, cool. That's pretty much the show. We'll be on tonight's show and tell, if everything goes well. Where's that? Do you see it? There it is. Thank you. There it is. So tonight we have Ask an Engineer. It's at 8 p.m. And before that, it's show and tell. This week, it's just a regular show and tell. Last week we had a special show and tell. Yeah. And some things happened, so we're there. But this week we'll be there. I'll put some LEDs on my eyes, and then I'll have the robot on my shoulder. So hopefully you can come and join us. Go to the YouTube page and chill there. We'll send you a chat link and an invite link when the time comes, and that's how you get invited.
Yep. Of course, you can always hang out in the Discord chat room too.
That's right. We got Discord chat rooms happening right now.
Keep a pulse on everything Adafruit.
Sure.
Chill out there.
And don't forget, support the channel. Support your maker habits by getting more maker stuff. Servo LED, 10% off.
Yep. I think that's it.
We got a Q&A.
Joining.
So catching up with the chat room. There we go. Hey, hello, everybody in the chat room. If you guys have any specific questions about the stuff, oh yes, Scott will be on the show and tell.
That's right.
And Engineer live with Lamar and Phil. So.
Yeah. So for those who just joined in yet, Scott is in the office. He'll be hanging around there.
Yeah. And John too.
Oh yeah, John too.
These are sight eyes, yeah.
I need some of those, yeah.
Can you enter the fidget design contest more than once? I'm not sure. I would check the rules and stuff in there. Maybe you can. I don't know.
See, John was saying sheet metal screws for mounting the...
Oh, right, yeah. So these are, maybe it's sheet metal. It's like zinc metal screws. Yeah, since the mounting holes are pretty far away from most of the I don't think there's any chance of shorting it or anything. We do have some M2.5 machine screws, nylon screws, so you can always go with those if you. Where's my arcade fix? Did I miss it? That's gonna be next week, actually.
Yeah, we just ran out of time.
I ran out of time. Yeah.
That will be next week. Super cool.
What? John's got a new robotic arm.
Oh, I think he showed a preview of that. That's so awesome.
Oh man, I
like to see that.
All right.
Christian is saying he's thinking about getting the 1mm nozzle to print at 0.8. So we did test out a 1mm nozzle from BCN. The only drawback to that was that we had to print slower.
You have to print slower.
So there's like...
Aiden, XYZ Aiden made a great video on experimenting with different nozzles. Yeah. And yeah, that was one of the things. You have to print really, really slow, and it just eats. There's so much filament.
Yeah, yeah.
Like crazy.
Yeah, usually on time-lapse, you can see like the spool just, you know, rolling around or spinning around with the 1mm nozzle. You see that in real time.
Sweet. Yeah, John just, yeah, he'll hopefully be on tonight.
Yeah, we'll make sure to send you a link.
Cool. And writers asking about the arcade project. Yeah, they'll have to be next week. Just ran out of time on this one since it was
Do we have it here just for a quick show?
No, I don't. It's over there.
Yeah. So we got 2 sizes of that.
Yeah.
Last minute size, upsize on that worked out really well.
All right. Well, thank you guys so much for joining us. Again, just a quick program note. We do the show live every Wednesday at 11 a.m. Eastern Time. So check it out. If you are watching this on the pre-recorded archive, you can join us live every Wednesday at 11 a.m. Thank you guys so much for joining us. Good luck with all your maker projects, and thank you so much for keeping it awesome. Something like that. Bye, everybody.
See you next time.